Welcome to Brain Vision.
So part A of this problem is asking which position is larger for really small values of t. And a way you can do this is by plugging in really small value of t, such as 0.01, and then just crunching the numbers in your calculator and seeing which one of these values is larger. Or you can notice that we have larger powers of t for b than we do for a. And so if we plugged in something like 1/100th of a second, these numbers are going to be really small because 1/100th squared is a really small number and 1/100th cube is an extremely small number. Also, we have a minus sign here, so we're going to be subtracting two small numbers, whereas for this one we're adding two bigger numbers. And so shortly after 0, t is equal to 0, xb is going to be smaller. But then you'll see if t is equal to 100 seconds, then these higher powers start to make b be much larger than a. And so I just like to solve this by intuition. And so by the reasoning I just said, b is a shorter distance away. Just after t is equal to 0. Part B is asking at what time are the two distances equal. And so to solve this, we just equate our two formulas for the positions, xa and xb. And so for xa, I have this, and I'm equating it to xb, which is this. For these problems where they give you a bunch of constants, I find it easiest to just leave them in terms of these parameters, alpha, beta, gamma, delta, rather than plugging them in. It just makes it go a little quicker. At this point, we can cancel t, and then we have a form for a quadratic equation so that we can use the quadratic formula. The standard form of that equation is this: beta minus gamma times t plus alpha is equal to 0. And so quadratic formula tells us that t is equal to gamma minus beta plus or minus the square root of beta minus gamma squared minus 4 delta alpha. And this is all over 2 times a, which in this case is 2 delta. Now at this point, you do actually have to plug in what these constants represent. I've written them down here, these 4 numbers here. Whenever you do that and crunch the numbers through your calculator, you get that t is equal to 2.275 seconds, and t is equal to 5.725 seconds. And so these are the 2 times where the two x values for a and b are equivalent. And that's part B. Part C asks us at which point is the distance between them not changing. And so the way I did this is I wrote down an equation for the distance between them, which is equal to xa minus xb. But xa and xb already have forms. And so plugging in those forms, I get alpha t plus beta t squared minus gamma t squared plus delta t cubed. This is a function of t, and it gives us the distance. If you plug in a value of t and then crunch the numbers, you'll get the distance between a and b. And we want to know when this is not changing. And so we have to take its derivative and set that equal to 0. So the derivative, I'm just going to denote by distance prime, is equal to alpha plus 2 beta t minus 2 gamma t plus 3 delta t squared. And we need to set this equal to 0 to find out when it's not changing. And so when we set that equal to 0, we once again get a quadratic because we have t squared, and then we have a large linear term here, and then our constant term. And so we can just plug this into the quadratic formula again. I'm not going to write out the whole step at this point. I'll just quote the answer because this is just like part B at this point. The two solutions for t are t is equal to 4.33 seconds and t is equal to 1.0 seconds. So these are the two times where the distance between A and B is not changing. And that is the answer to part C. Part D asks us when the accelerations are equivalent. And so we have to start taking some derivatives of our position functions. So just recall that xa is alpha t plus beta t squared. To get the acceleration, we have to first get the velocity. And we get the velocity by taking the derivative of the position. So the velocity of A is alpha, just the derivative of that, plus 2 beta t, which is the derivative of this term. And then from that, we can get the acceleration of A, which is just the derivative of this. The alpha goes away, and we just have 2 beta. We need to do the same thing for B. Recall that xb is equal to gamma t squared minus delta t cubed. Taking the derivative of this gives us the velocity. And so it is 2 gamma t minus 3 delta t squared. And then taking the derivative of this gives us the acceleration of B, which is 2 gamma minus 6 delta t. Now we want to find out at what times these are equivalent. So we equate them to each other and solve for t. So equating them gives us this equation. We can cancel 2. I'm also going to bring this term over here, and I'm going to bring the beta over here. Whenever I do that, I get 3 delta t is equal to gamma minus beta. So t is equal to gamma minus beta over 3 delta. And you have to plug in the constant values, which are given here, into this expression. When you do that, you get a t value of 2.67 seconds. And that's the end of the problem.